Hello, I'm Dr. Andrew McDonald from La Trobe University, and welcome to Far Labs. So this Far Labs experiment is all about radioactivity. So you'll be playing with some real radioactive sources and trying to understand how difficult that radiation is to contain. So for the radioactivity turntable experiment, we go to nuclear. Then under the turntable section, we go to explore. So on the left here, we've got a number of experimental stations we can use. Your teacher will have booked one of these for your exclusive use. So we'll use turntable number 3. So you should see here a live video feed of the radioactivity turntable experiment, which is located at La Trobe University. On the left here, these are our real radioactive sources here. In the middle, this is our radiation detector. It's called a Geiger counter, and it measures the amount of radiation getting from the source and into the detector. And this is recorded as the counts, which are shown up here. So to interact with our Far Labs remote experiment, we need to log in. So your teacher will have given you a password. So let's log in. And once you've logged in, all these buttons appear down the bottom. So the buttons on the left allow you to move between different radioactive sources, and you can see in the video feed the turntables turning around. So there are a number of different radioactive samples we can select. We've got an alpha, a beta and a gamma source. So these are different kinds of radioactive sources which we'll explore in this experiment. So let's select beta. On the right, these buttons allow us to place a number of absorbers or barriers between the source and the detector. So let's select none to begin with for no barrier. And if we look at our counts up here, we can see the number fluctuating between 140, 150, 120. So let's select the plastic barrier now. And while the numbers are still fluctuating quite a lot, we can see that overall the number of counts has been reduced significantly. So what we need to do is we need to record these counts over a small time period like 30 seconds and then take an average. So we can do that by writing down these numbers, or we can use the plot down here which is recording these numbers for you, and we can even create an image from this plot which is a snapshot in time, and then we can save this to a suitable location, and then we can collect these and use them later to work out our averages. So what you'll be exploring in this experiment is not so much the actual values of the counts here, but how much these numbers decrease between having no barrier and a barrier between the source and the detector. And we want to do this for all the different kinds of sources to understand how good they are at going through these barriers. So remember, the actual numbers don't matter. All that matters is how much they change when you go from no barrier to having a barrier. So I'll give you a little clue. One type of radiation is really bad at going through barriers, another type is really good at going through barriers, and the other is somewhere in between. So if you figure this out, then see if you can guess what the unknown source is.